you all are fine. In the last session, we have discussed about the one-dimensional motion, two-dimensional motion, and three-dimensional motion. And I hope you have written the definition. We have seen the example which motion is called one-dimensional, which motion is called two-dimensional, and which motion is called three-dimensional. Also, we have learned the concept of the motion. Okay. Now, today we are going to discuss the path length and displacement. So, what we mean by the path length? Take an example that you are moving from your home and you went to your friend's home. Okay. Together, you are moving to the school, and then you come back to your home. Okay. During this journey, the amount of the total distance covered by you, that is called path length. Okay. So, what is the path length? Total distance covered by the particle is called path length. One more important thing is that it is scalar quantity. What is the scalar and what is the vector? We will see its definition, but right now it is scalar. Okay. But the thing most important is that whenever you calculate the path length, you should not bother about the direction of the journey. If you are moving from your home to school and you come back from school to home, so the calculated distance should not be subtracted. Likewise, if the distance between your home to the school is 5 km, so you are moving from your home to the school 5 km, and from back school to your home total 10 km. Right? So, whenever you are calculating the path length, you are not bothering about the direction of the journey. You just remember that how much amount of the distance you have covered in that period, you have to take only summation. Okay, so that is the path length. Okay, so we are writing definition of the path length. Okay, so what is path length? Total distance covered by the particle or object is called path length. Okay, it is indicated by x, delta x, s, delta s, whatever you can take. It is also indicated by r also, delta r also. Choice is yours, but it always measured in meter because it is distance, and we have learned in SI system the distance is always measured in the meter. Okay, so SI unit meter. Okay. One more thing, that it is scalar quantity. And it can be zero or positive, but never negative. Okay, इसका मतलब if object is steady, then path length is zero. उसने distance ही cover नहीं किया. If it starts its journey, then the distance covered in either direction always positive. It never negative. कभी भी वो negative नहीं होगा. ये इसकी important characteristic है. Okay, and it is scalar. So what is the definition of the vector and scalar? We will start by this definition in the chapter number 4. But right now I give you the idea that scalar quantity, to describe that physical quantity you only require the magnitude. Okay, आप magnitude दोगे और पूरी information आपको मिल जाएगी. Okay, जैसे कि path length, second है आपका temperature, speed. Okay, उसमें आपको direction से कोई लेना देना नहीं है और जैसे ही आपको मैं वैल्यू देता हूँ आपको उसके बारे में पूरी इंफॉर्मेशन मिल जाती है. दैट्स कॉल्ड स्केलर क्वांटिटी. वेक्टर क्वांटिटी में आपको वैल्यू भी देनी पड़ेगी और डायरेक्शन भी बताना पड़ेगा. ओके, सो व्हेन द फिजिकल क्वांटिटी रिक्वायर द मैग्नीट्यूड एज वेल एज डायरेक्शन, दैट फिजिकल क्वांटिटी इज कॉल्ड द वेक्टर फिजिकल क्वांटिटी. ओके, लाइकवाइज वेलोसिटी, momentum, acceleration, force, this all physical quantity are vector where you require the magnitude as well as direction. Okay, so this path length is a scalar physical quantity. You need not direction. Okay, and it can be positive, it can be zero, but never negative. Okay, idea आ गया होगा? I hope. चलिए आगे बढ़ते हैं. Second is displacement. दूसरा क्या है? Displacement. So, by the definition, change in position is called displacement. फिर से रिपीट करता हूँ. Change in position is called displacement. Okay? Formula बहुत आसान है. Final position minus initial position, that is called displacement. Okay? यानी कि आपने जर्नी की शुरुआत कहीं से भी की है, that is called initial point. और आपने जर्नी जहां पर खत्म की है, that is your final destination, final point. Initial and final. इन दोनों का आप सब्ट्रैक्शन ले लोगे. Final minus initial, that is called change in position. आपने कितना चेंज किया ओके अपनी पोजीशन में, दैट इज कॉल्ड डिस्प्लेसमेंट. अगर आपकी इनिशियल पोजीशन एंड फाइनल पोजीशन सेम है तो डिस्प्लेसमेंट ऑलवेज जीरो. जैसे कि आप घर से निकल के हमेशा वापस कहां जाते हो? घूम फिर के वापस घर. सो डेली डिस्प्लेसमेंट इज जीरो बिकॉज़ योर इनिशियल पोजीशन एंड फाइनल पोजीशन एट द एंड ऑफ द डे इज सेम. एंड फार्मूला फाइनल पोजीशन माइनस इनिशियल पोजीशन, that is so called displacement. Okay, might be possible in a day you have traveled 100 km, but after all traveling this journey you have come back to the home, so your path length is 100 km, but your displacement is zero. Okay, by the formula, right? So first we are writing the definition. So definition is change in position is called displacement. Okay, formula final position that is indicated by x2. Okay, minus initial position okay, and that is so called displacement, and that is indicated by delta x. This also can be indicated by delta x. This also can be indicated by delta x. But you have to mention we are talking about the displacement or path length. Okay, by the indication there is no any difference. That is the reason. Okay, चलिए अब हमारे पास फॉर्मूला देखिए आ रहा है. ओके, ये क्या आ जाएगा? x1 लिख देना हूं यहाँ पे x1 that is x. Simply show कर देते हैं that is x2 minus x1 that is delta x. Again, the SI unit is meter, indication is small. Okay, so delta x is called displacement and it is the vector physical quantity. So we will write displacement is vector physical quantity. Okay, so as per the definition you have to take care about the direction. Okay, one more thing, it can be zero, it can be positive, it can be negative. Okay, it can be zero, positive, or negative. Okay, but it cannot be, it never be greater than to the path length. Okay, आप किसी भी टाइम इंटरवल के लिए आप ऑब्जेक्ट की जर्नी के लिए पाथ लेंथ कैलकुलेट करो, डिस्प्लेसमेंट कैलकुलेट करो, वो दोनों इक्वल हो सकते हैं. ओके, ये स्मॉल हो सकता है पर कभी भी ऐसा पॉसिबल नहीं है कि द डिस्प्लेसमेंट इज ग्रेटर देन टू द पाथ लेंथ. It never been like that. Okay, so it is most important characteristic is that it meaning कि displacement never greater than okay, it might be equals, it might be less, but it not never be greater. Okay, displacement path length जितना हो सकता है उससे छोटा हो सकता है, बट कभी भी उससे क्या नहीं होगा, ज्यादा नहीं होगा. ये आपको हमेशा ध्यान रखना है. ओके, सो हियर वी हैव सीन द पाथ लेंथ एज वेल एज डिस्प्लेसमेंट. ओके, तो इसका एग्जांपल लेते हैं छोटा सा और फिर खत्म करते हैं. कैसे और क्या है समझते हैं. चलिए, कंसीडर एन ऑब्जेक्ट moves in positive x direction ओके. फिगर में इंडिकेट करता हूं. पहला सवाल है, इसके लिए आपको क्लियर कट पता चले इसलिए फिगर ड्रॉ कर रहा हूं, फिर वर्बली कैलकुलेट करना आप धीरे धीरे सीख जाओगे. ओके, चलिए. सो 0, 5, 10, 50. ओके, -5, -10. अब शुरुआत करना है वो ए पॉइंट से. जैसे कि मैं यहाँ पे -5 पे लिखा रहा हूँ, चलो 0 से लेते हैं. दैट इज स्टार्टिंग फ्रॉम द ए एंड मूविंग टुवर्ड्स द बी. ओके, then it's continued its journey to the point C. Then it's come back and it completes its journey at the point D. Okay, तो टोटल जर्नी का आपको पाथ लेंथ एंड डिस्प्लेसमेंट निकालना है. ओके, और यहाँ पे आपको यूनिट दे दिए हैं. हर एक इंटरवल आपका कितना है, 5 मीटर का है. चलिए, सो आपको पाथ लेंथ के लिए क्या करना होगा, आपको क्या करना होगा, ए से बी तक का डिस्टेंस, बी से सी तक का डिस्टेंस और सी से डी तक का डिस्टेंस, टोटल डिस्टेंस को क्या करना है, सम अप करना है. ओके, चलिए. तो मैं क्या कर लेता हूं, ए बी प्लस बी सी प्लस सी ओके, अब ये कैलकुलेट नहीं करना, ये खाली जो एरो है या लाइन है वो सुपरपोज ना हो जाए इसके लिए मैंने ऊपर दिखाया है। ओके, बट इट इज मूविंग इन द सेम डायरेक्शन। So, first criteria, whenever you calculate the path length, you should not bother about the direction, how much amount of the distance you have covered, you have to do only summation. आपको क्या करना है? टोटल ही करना है, राइट? चलिए, तो A से C तक का डिस्टेंस कितना? तो यहाँ से 0 से शुरू की और A से B तक का डिस्टेंस 5 to 10, यानी कि टोटल 10 प्लस B से C 10 से 15, बराबर। बट डिस्टेंस तो कितना कवर हुआ? 5। इंटरवल कितने का है? 5 का, so that is 5 प्लस अब C से D तक का फिर से 15 से 10 जाओगे तो 5 और 5 10 से 5 आओगे तो वापस 5। सो टोटल इंटरवल फिर से कितना हुआ? टोटल 10 मीटर ट्रैवल किया, so टोटल 10। ओके, तो ये टोटल आपका बन जाएगा 25 मीटर। सिंपली कितने इंटरवल से वो कैलकुलेट भी कर सकते हो। कैसे? देखिए 1 2 3 4 5 इंटरवल कवर हुए, हर एक इंटरवल कितने का है? 5 का, तो 5025 मीटर डिस्टेंस कवर हुआ। ओके, डिस्प्लेसमेंट कैलकुलेट कर लेते हैं। वेरी सिंपल, डिस्प्लेसमेंट का फॉर्मूला क्या है? x2 माइनस x1, सिंपल। फाइनल पोजीशन कहां पे रुका? ओके, फाइनल पोजीशन B पे रुका, दैट इज 5 पर है। ओके, सो दैट इज 5 और इनिशियल पोजीशन क्या थी उसकी? 0, तो माइनस 0, तो यू कैन से टोटल 5 मीटर उसका क्या हुआ? डिस्प्लेसमेंट। So there we have calculated path length is 25 meter and the displacement is 5 meter. फिर से क्या ज्यादा है दोनों में? path length। ओके, ये डिस्प्लेसमेंट कम है, ये नेगेटिव में भी आ सकता है। ओके, चलिए, तो just we have look what is the path length and displacement. Okay, now we are going to discuss the few numericals regarding that. Okay, so here we are going to understand in different numericals how we can analyze the concept of the displacement as well as path length. Okay, just we have checked the characteristics of the path length as well as displacement and what is the formula. Okay, now in the numerical the thing is given, a person is traveling towards the north and tends to the north. Okay, 5 kilometer, and then he takes the right turn and covers the 6 kilometer distance. Calculate the path length and displacement. Okay, now always remember you have to follow the sign convention according to the map method. Means this always considered as a north direction, this is the south, this is the east direction and this is the west direction. Okay, this sign convention always follow in such kind of a numerical where the direction north, south, east, west is here. Okay, so here according to the question, he covers the how much distance? 5 kilometer distance towards the north. So I put an arrow towards the north and I will indicate this is the 5 kilometer. Okay, now he takes the right turn in this direction. So I will put an arrow in this direction and covers the 6 kilometer distance. Okay, so let it give the point A and this is the D. It is intermediate point C. You can say like that. So total path length is quite easy. That is 5 km plus 6 km. That is 11 km. No problem over there. But how to calculate the distance from point A to B? This is the initial position and this is the final position. You cannot take the directly subtraction final minus initial. if it is in a one direction, unidirectional, then you can take the directly subtraction. But over here, this is the two dimensional, you can say like that. Okay, so here you have to use the concept of the Pythagoras. Okay, so AB is equals to, you have the idea under root of AC square plus CB square. Okay, and that is AC is equals to, you have 5, so 25. Let me put first 5. 5 square plus CB is equals to 6, so that is 6 square. Okay, and that is all about 25 plus 36, and that is under root 61, and unit is kilometer. Okay, you can get out the friction value of this root 61, whatever it is. Okay, so this is the what you have find out, this is displacement. And path length is path length, that is equals to 5 plus 6, 11 kilometer. Okay, so here we have solved in one case that what is the path length and what is the displacement. Okay, one more numerical is given in the fashion of one particle or one person or one object, anything is given that covers the distance in x direction, y direction and z direction. Okay, whenever all three direction is been given, then at that time you have to take the common formula which is represented as r. Okay, r is equals to under root of x direction x square plus y direction y square plus z direction z square. Okay, all the magnitude of the directions you have to take square and root, that is called magnitude. Okay, so we directly put that for r is equals to under root of x, 3 meter distance in x direction, so that would be 3 square plus 5 meter distance in y direction, so that is 5 square plus 7 meter distance in z direction, that is 7 square. Okay, and therefore r is equals to under root of, that is 9 plus 25 plus 49. Okay, that is r is equals to under root 113 almost meter. Okay, what is the path length? So for the path length you have to calculate the meter plus 5 meter plus 7. Okay, so that is quite simple. 15 meter is the path length and this is the displacement. So here we have seen the concept of the path length and displacement. This is quite simple and mathematical that we have over here. Step by step we will cover some critical time numerical in the future reference. Right now we move further. One more topic today we are going to cover, that is the average speed and average velocity. Okay, so now we are going to discuss about the average speed and average velocity. Okay, so what is the difference between speed and velocity? First, so by the definition and by the formula, in one case in speed you are going to utilize the fundamental of the path length, whereas in the velocity you are going to use the fundamental of the displacement. Okay, so I write the first definition. Average speed. Okay, so definition is the ratio of path length, okay, the ratio of path length to total time is called average speed. Okay, you also can say that the total distance covered by the particle in that particular interval of the time is called path length. Okay, as you know that the path length is indicated by delta x, okay, delta s, delta r, delta y, delta z. You can take any symbol, no problem over that. Okay, and the interval of time or total time is indicated by delta t. So by the formula it would be delta x upon delta t, and the symbol of the average speed is delta v or v bar. Okay, so we will write average speed is indicated delta v or v bar. Okay, and the formula just we have learned that delta v is equals to delta x upon delta. Okay, so unit would be delta x. Just we have look path length, that would be measured in meter, and the time always measured in second. So meter per second is unit of average speed or velocity. Okay, यहाँ पे और इंडिकेट कर देता हूँ, डेल्टा v या फिर इसे v बार से भी इंडिकेट किया जाता है. Okay, so all the characteristics which can be applicable to the path length, that all characteristics you can apply to the average speed. यानी कि जो भी कैरेक्टरिस्टिक पाथ लेंथ की है वो सारी की सारी कैरेक्टरिस्टिक एवरेज स्पीड की होगी. किसकी होगी? एवरेज स्पीड की होगी. यानी कि the average speed is scalar quantity. Okay, it can be zero, it can be positive, but it never negative. Clear? Okay, so right now I am not going to write that things because we have written in the case of path length. Okay, I am going to write directly one concept or one thing. Your odometer. What is odometer? The speedometer in each car or the bike or the racing cycle, etc. Okay, that indicates the speed. Okay. have possessed or at what speed you are moving, that odometer indicates on an arrow sign that is speed or velocity. Question is that is speed. Okay, तो क्या होती है? स्पीड होती है, कभी वेलोसिटी इंडिकेट नहीं करती है. Okay, so an odometer always indicates, and use one more word that is called instantaneous. Instantaneous speed. Why I use this word? Because we are just going to move from average to instantaneous. Okay, यानी कि अब हमें एवरेज और इंस्टेंटेनियस के बीच का फर्क पता करना है. ओके, बट उससे पहले आपके सामने मैंने वर्ड रख दिया है. एवरेज का मतलब होता है एवरेज ऑफ द टोटल पीरियड ऑफ टाइम, एंड इंस्टेंटेनियस का मतलब होता है ऑन द स्पॉट, राइट नाउ. ओके, वहां पे कोई बड़ा इंटरवल नहीं होता है. बट to move technically, mathematically and conceptually from average to instantaneous, we have to learn the derivation. Okay, so in the next lecture we will cover the concept of the derivation, but before that we have to cover the both characteristics of length as well as displacement. So next is our average velocity, right? So what is average velocity? Okay, so by the definition it is the ratio of displacement to the interval of time, or an interval of that time is called average velocity. Okay, so ratio of displacement to interval of time is called average velocity. Okay, so again I am distinguished between the average speed and velocity. Here the ratio of path length, and here the ratio of displacement over the interval of time. In both cases it is quite simple, but speed, then it is path length, velocity is displacement, right? Okay, so therefore delta V is equals to delta x by delta d. Okay, but here you have to indicate this is delta x, so it is x2 minus x1 displacement, and here it is p2 minus p1. Okay, here what you can indicate x1 plus x2 plus x3 up to x4. How much distance it is? p1 plus p2 plus p3 up to how much distance it is. Okay, चल तो यहाँ पे इंडिकेट कर देता हूँ. So here the delta v you can write that delta x by delta d, and that is what x1 plus x2 plus x3 up to जितने भी डिस्टेंस कवर किए हैं in interval of t1 plus t2 plus t3 and so on. Okay, so that will lead you to total time, and that will lead you towards the total distance. Over here x2 minus x1, that leads you towards what is the displacement, change in position only, and this is the interval of time, that is t2 minus t1. Okay, again all the characteristics which you have given to the displacement you can deploy to the velocity. यानी जितनी भी characteristics आपने displacement को दी है वो सारी की सारी characteristic आप velocity को भी दे सकते हो. Okay, so by the fundamental I have explained what you mean by the velocity and the speed. In next session we will elaborate this both case and we will look some more fundamentals as well as the numericals of the average speed, velocity, path length and displacement. Okay, hope you have enjoyed the lecture. Take care. Bye bye.